A very good morning to one and all. So, heading towards the first session of the day, I would like to welcome Dr. Ravi Kumar Mandawa. Uh, Welcome, sir. So,
Yeah.
about Dr. Ravi Kumar Mandawa, he's an assistant professor in Department of Mechanical Engineering at Maulana Azad National Institute of Technology, Bhopal. Uh, he did his PhD in 2019 in mechanical engineering, especially robotics, from IIT Bhubaneswar, and he did his Master of Engineering in Mechanical Engineering, CAD, especially CAD CAM from Andhra University, Visakhapatnam, Andhra Pradesh. He did his BTech in 2008 in Mechanical Engineering from Acharya Nagarjuna University, Andhra Pradesh. So he's having experience of 6 years in teaching and research. In his specialization in robotics, soft computing, and manufacturing. And publication, he has published more than 40 research paper, including 15 SCI and 4 international book chapters, uh, 6 national lecture notes, 1 national conference, and 14 international conferences. He's an active member of IEEE, and he received Best Paper Award for study on influence of hip trajectory on the balance of a biped robot, uh, presented at ICE CIT 2015, Anandpur, published by Lecture Notes on Electrical Engineering. He is working on funded project, design and development of coconut harvesting robot worth of rupees 23 lakh 16,600 under the scheme of Young Scientist and Technologist DST. He has a lot of administrative experience also as a robotics lab in charge and technical committee member in Tinkering Lab and co-coordinator member of Rolta Incubation Center, Manit Bhopal. And he's an active reviewer of International Journal of Dynamics and Control, Springer, International Journal of Intelligent Service Robots, Springer, International Journal of IET Control Theory and Application, IEEE, Engineering Reports, Wiley Online Library, Journal of Control Science and Engineering, Hindawi, and Silicon Springers. So this is some few about Dr. Ravi Kumar Mandawa. So I welcome you, sir, and I request you to kindly
thank you, Dr.
proceed.
Vishwanath ji. 1 minute. I think my slides are changing or not now.
Sir, please try.
Is there in first? It is changing. Slides are changing. Just I am checking.
No, sir, no.
No.
Slide is not changing.
1 minute. Okay. I think now it is changing.
Now it is changing. Yes. Now it is.
Okay. Thank you. A very good morning to all of you, and a warm welcome you all for this today's session. I think today is the last day of your program. This is the one of the ATAL program in the field of Internet of Things. I think maybe for the last 4 days, you may aware of maybe the keynote speaker, the renowned keynote speakers. Maybe they have already discussed about what is Internet of Things. Okay, and also they may have discussed about how the Internet of Things helpful in various applications. But today I'm going to cover the one of the emerging technology. The people nowadays, their the mouth word is coming. Everyone mouth word is coming is a robotics. Actually, when we are going to already people they know about robots when they have started in 1920 or 1950 or 1970. They have started some robots. It is purely applicable to industrial version. They have developed the robots when they have developed initially. They have used for only for industrial application, but slowly the researchers they are working on how these robots are helpful in different types of fields like for agriculture applications, medical applications, military applications, and also they are using how it is in societal applications, how these robots they can use in from motion planning applications. I think maybe most of the people they are aware of that the driverless bus. These are all the things. See, when they have started, it is a industrial purpose, but slowly these robots are coming into the picture in the different types of fields, like what I said, medical, agriculture, and societal applications. Actually, I have worked for the last 6.5 years onwards. I am working on the robotics. I have started into my journey in 2014 as a PhD scholar in IIT Bhubaneswar under the supervision of Dr. V. Panduranga. I have started in bipod robots. In my for 4 years, I completed in related to bipod robots. Bipod robots is nothing but it is similar to humanoid robot. We how human is working the same similar mimic structure we are trying to operate by robot. Why? Because where the robot is not possible, where the human is not possible to go there, in the place of human being we are trying to mimic the humanoid. Okay, in the place of human being we are going to put in humanoid robot. In the similar way, after that, I have joined in Vignan University. It is a deemed to be university in Andhra Pradesh. We have worked in some agriculture robots, like how the robot is cutting the grass. Then also actually how it is used in surveillance applications, and also I have worked in one agriculture robot. I can show that one also at the end. It is how the robot is climbing the tree. Okay, actually the main purpose of the robot we have developed for cutting the coconuts. Okay, this is the project we have received from DST in the scheme of young scientist and science and technology. This is the thing. Then see what I said earlier. They have started robots in industrial purpose. Then they have moved into the different types of application. But people are working, but the people are controlling with joystick, or it may be people are controlling with their laptop in front of the robots only. They are sitting and they are controlling. But actually, what this Internet of Things, it came buzzword recently. The machine learning algorithms, Internet of Things, okay, artificial intelligence. See what these Internet of Things will do. You can sit anywhere, wherever you comfortable. You can sit in your home also. You can control your robot by using your mobile, or you can control by your any tablet. You can control the robot. That is the technology is called Internet of Things. That the people now slowly they are going to introduce this thing into the agriculture applications also, like how they are controlling. See nowadays actually they are called as industry 4.0. What is this industry 4.0? Industry 4.0, it is the combination of actually whatever the data science, machine learning algorithm, and Internet of Things. See here, actually, what happened? The mission to mission communication. There is no need of human being. It will control. It is the communication between the mission to mission, and finally, you will get your product. See, we are going to mix with all these technologies like Internet of Things, like machine learning algorithm, like artificial intelligence, like robotics. Okay, we are going to mix all these technology into the industry. Then only it is a smart industry. It is called as a smart industry. What it will help? One is the Internet of Things. You can control your robot from where you comfortable. You can sit on there, and you can control number of robots, and you can take the data from data science. You can collect the data, okay, and by using some cloud computing, and also you can use some intelligent also. Okay, how the mission, if you want to communicate with the other mission, how your robot want to communicate with the other mission, or robot to robot communication. And also you can understand when the mission is going to shut down. Okay, when the mission is when it is going to maybe failed some component in the mission. Okay, I think my voice is audible. If any problem is there, if it is not audible, please inform immediately, okay, through WhatsApp. This is the thing of the smart industry people they are working. But nowadays actually people they are moving to slowly into the agriculture, for agriculture application. How it is a smart agriculture? How it is a smart agriculture? How we know it is a smart agriculture? We can interrupt whatever the technology we are going to use in the industry. The same technology we are going to involve in the agriculture field also. How the farmer, see nowadays actually you can see, you can go village. Actually I came from village background. I have seen in my village nowadays people are not interested to do farming. Why? Because there is a lack of, first the problem is that lack of labor, and the labor cost is increasing. There is a few people are labor is there available, and the cost is increasing. The first thing is this is the problem, and the second one is what type of diseases are coming in the farm. Okay, if you are going to paddy or corn, what type of diseases are coming, that also they cannot see. Nowadays there is a lot of diseases are coming. And see, recently the COVID also, for as a human being, the COVID, we cannot expect this type of disease will come like that. In the agriculture application, agriculture fields also, there is a lot of diseases are coming. And also you don't know when the rain will be fall down, what is the climate conditions. Okay, after 2 months, suppose if you start to do cropping, okay, if you start to do put seeding in the soil, but we don't know when the floods will come, when the heavy rain will come, okay, when the drought will come, we don't know. These all the climatic conditions, there is a one problem. One is the labor cost, second one is the climatic condition and diseases, and the other one is the what type of disease coming, and according to the diseases, what type of pesticides I need to use it, what type of pesticides I need to use it. Then one more problem, when we are going to discuss about these agriculture, whether the soil is such a type of nutritions and available or not. Whether suppose if you are going to do some farming, what type of crop you are going to put in the farm, that it is related to the crop, what type of nutrients is required, whether it is available or not. These are the things. And coming to when you go for like management, like your cows, goats, sheep, these are all the things, hence, okay, when they, this is the secondary income of the farmers, when they are farming this type of cows, goats and sheep and hence these things. And there is a problem to do how the age is going and what type of health is there inside. Okay, and how many goats are there per counting, and also it is also a very difficult for to make comfortable to all these things. Actually now the people have started to work in these internet of things. Actually what will happen in the internet of things, there is a cloud and there is a sensor. Initially the sensor will take the data and it will send to the cloud, and it will be processed there. There is a database, is the data collection and database. From there you will get it, what is the growth of the cattle, and what is the growth of your crop, when it is, what is the climatic conditions, and all these things will be go to the server. Okay, suppose if you are going to discuss about the climatic condition, you will take the data from the climate. Okay, the climate atmosphere, you can take the data, and with that data it will correlate, and if due this type of temperature, this type of humidity is there in the atmosphere, when the rain will come, when the floods will come, they will, and what seeds, what type of crop is suitable for this place, these are all the things it will guide. This is the thing, that's why the people they have started to do these internet of things in the agriculture fields. And see, in the agriculture fields also, see, they are using robots. Okay, but earlier they are using robots with you as a human control they are using, but now these all the robots also controlling by internet of things. And see here, I'm going to discuss about first what is the history of the robot. See, the term robot has come from the Sage word. It is a robota, which means force or slave labor. See, when they have started robot, it is initially it is a like a forced or slave labor. That means it will do whatever the labor work we are going to do. That work this robot can do it. And this robot, it is coming from, it is a Sage word, and it was invented in 1921 by Karl Kappak. Okay, he's when he has developed this term robot, when he is writing one drama, he's actually a stage playwriter, and when he's writing his drama, he has identified this Rosam's universal robots. And according to perception, I said it is a work what human is doing. Okay, whatever the work is done by human being, and that work can possible do by robot also. This his perception is that when he started this, but the first digitally operated and programmed robot. Okay, what he has done in 1921, he has found the term robota. Okay, in his drama, but the first digitally operated programmable robot was invented by George Dowell in 1954. That is called Unimate robot. That is called Unimate robot. It was developed by Unimate company. It was developed by Unimate company. This robot especially they have used for initially when they have developed this robot, especially they have used for only for pick and place operation for industry. Okay, suppose if you want to do for picking and placing somewhere, they have used this robot as in terms of in the place of human being, they are replacing this robot. And coming to the introduction to robots, see, when the people they are thinking about what is robot, what is robot? See, it is a mechanical device. Robot is a mechanical device, but it is artificial intelligence. Okay, see, it is a mechanical device, but it have artificial agent and is usually an electromechanical system. Why? Because it is not a completely in mechanical system, it is an electromechanical system. See, why it is electromechanical system, it consists of a mechanical devices are there, and also for moving from one place to another place, you want to use some actuator. That's why it is a electromechanical system. Okay, there is a actuators, and if you want to write the programming, and if there is a sensors data, that's why when they have started this robot, it is not in mechanical device, it is a completely electromechanical system. It is a electromechanical system. And see, it is a device that because of software programming makes complicated tasks easy to perform. See, based on this programming, okay, based on whatever the software programming, okay, like in artificial intelligence, like machine learning algorithm, whatever the complicated things are there, that complicated things we are going to can perform in very easy way. Now you can see the some of the pictures I have shown in here in the agriculture application. See, the first one is the plucking operation. Plucking operation. See how this robot. See the complete robot. It's a mechanical structure, but it is a mechanical structure, but it have plucking the robot, plucking the tomato. Okay, plucking the how it is plucking by using some electrical actuator, by using some electrical actuator, and also how this robot knows it is a tomato and it is ready to cut, and some electronics gadget. Okay, some gadget like camera they are using or some sensors they are using. See how it will it will pluck it exactly. It will take the picture. See, it will do the image processing analysis. Then robot can identify based on its previous data. Already it was there. There is a stored data, and it can check this food can ready to pluck or this vegetable can ready to pluck. Then only it can pluck it also. But and you can see here when we are going to pluck it. Okay, here plucking. If it is a mechanical device, if you are using completely mechanical arrangement here, what will happen when it is pressing? When it is going to pluck it, what will happen? This will be spoiled. This okay, whatever the item we are going to pluck it is a vegetable or fruit or egg, whatever it may be, it will be spoiled. Okay, for that purpose, nowadays people are working on soft robotics. People are working on soft robotics. Actually, this soft robotics, you see here, it will works based upon the pneumatic device. It will works based upon the pneumatic device, and this soft robotics can useful for to picking, okay, or to plucking like light very thin parts, okay, like egg, like tomato, apple, these very thin parts. It is very difficult by using mechanical gripper. That's why they are using this soft gripper. And also see this robot they are using surveillance applications. See what will happen when you are going to farm something, any crop, okay, in the field. Any doubt? Okay. Any crop, when we are going to do any crop in the field, what will happen? Sometimes it may be night or daytime. Some maybe inserts, some inserts, or it may be some animals will come and it will create the. Maybe it may create and it may be harmful to that crop. Okay, it will try to damage the crop. Okay, to avoid that type of inserts and animals, and we are going to use some robots. That robot, what it will do, it will always continuously it will move in the field. It will move in the field and it will try to make it different types of sounds to create to fear, for that inserts or it may be animals. Okay, and also it will make different types of lights in the night time. Then what will happen, whatever the animals or insects are coming to damage that crop, and it will try to fear and then it will go away from the crop. And also see there is one more application. They are using robots, they are using inspection purpose. See here what will happen with these robot is moving on the complete on the farm, and it will try to detect each and every plant. It will try to detect each and every plant by using some sensor camera. Okay, what will happen? It will take the image and send the image continuously to the processor. And what will happen here? The processor will be check it. Okay, if it is there any disease are there, or if any new disease are coming, what type of disease is coming. And if suppose some plant leaves are different, then it will immediately check with okay, this type of leaves are coming, what type of diseases are there, and it will check with their cloud data immediately. Then it will suggest what type of pesticide is required, what type of disease is there. And these are all the different types of tasks they are using in agriculture. One is the plucking operation, surveillance, inspection, and I will discuss later also. It are different types of applications that these robots. And see why robots are required. Why it is required? Okay, without robots, what will happen? See, robot plays a significant role in agriculture to perform different kind of operations. Okay, it will significant role. It is performing a significant role in agriculture to do different types of application. Robots can build a performance capability superior to those of human beings. See, whatever the work we are going to do by human being, okay, when but the same work we can do by robot can do better quality, okay, better capability, okay, better capability than human being. Okay, I will give some examples here. Suppose if you are going to put the fertilizer for each and every plant. Okay, when you are going to use the human being, what will happen? He cannot use exactly for each and every plant. Why? Because it is the repetition work. It is the repetition work. He's feeling bored to give the fertilizer for each and every plant. Just he's throwing. Okay, he's throwing sometimes. If you go for in your farm, you can observe clearly. See, when you're going to use the human, you are taking any human power for a paid basis. What they will do, they cannot apply exactly in each and every plant. Sometimes they will do it. Sometimes what will happen after 1 hour, after 2 hours, they can spread little bit. Okay, but sometimes what will happen due to this type of spreading, the whatever the fertilizer, whatever the nutritions you are going to provide, that will not go for each plant. Okay, it may all the nutritions will go to some plants, and some plants maybe it may loss of that nutritions. Okay, the fertilizer it will loss. For that purpose, you can use robots. The robot can go there each and every plant. It can drop exactly at the root position where the root is there. Exactly, it can drop it. And robots are better than humans to perform simple and repetitive tasks which are better quality and consistency. Okay, whatever we have discussed. And robots do not have limitations and negative attributes of human work. What will happen when we are going to use these robots in farming? Robots don't have any limitations. Okay, I don't take any rest after 2 hours, after 3 hours, I don't have need like rest. But if you're going to use as a human being need some rest, and it may have some negative attributes also when we are doing some work. Robots are used in farming to save the time compared to human being. And robots are in value poor working condition. Poor working conditions may suppose if maybe if you are working in farm, here if you some fertilizers or some, what will happen, or some it may be harmful to human being, harmful to the human being. He may face some diseases later stage, or if he may die also sometimes due to, okay, due to the smell of the pesticides or fertilizer. You can use that type of poor working conditions. You can use the robots, and robot don't have any problem. It cannot die. Okay, it may not get any diseases. Improved work conditions and reduced risk. Okay, what will happen? These robots can improve the work conditions and reduce risk. And robots will replace the conventional techniques. Okay, what will happen? Whatever the conventional techniques we are using, okay, whatever the that means conventional, whatever the adaptive technology. See, already the people in the village, they have adapted some technology. Okay, that will be removed. Okay, robots will replace that adapted technology. Okay, will remove it to perform same task efficiency. Okay, whatever the task they are doing, okay, by you suppose if you are going, they are doing some weeding operation, some plugging operation. Okay, some operation if they are doing, they have already habituated some their indigenous technology. They have already habituated this indigenous technology. That technology will be replaced with by robots, but the same efficiency we can get it. Okay, how human is doing the same efficiency, we will get better, the task better way also we can do it. Applying applying automation agriculture has helped to create several advancements to the industry while helping farmers save money and time. Okay, whatever these all the things, how we are going to automation. See how industry we are going to use in automation. Okay, industry in automation means what we are going to do without any human intervention. From you are supplying the raw material and you will get the final of the product. You will get the final required product we are getting without any human technology in between, no human intervention. Okay, suppose if you are going to manufacturing any soap, or if you are going to manufacturing any mechanical bearings or mechanical gears, or if you are going to manufacturing, you are supplying only raw material, but final the product you will get it out. That is called a completely automation. That means you mission to mission, one mission to another mission, the product is changing. How it is changing one mission to another product? Only the in the place of human being, the robots can go there and it can take the object after completion of the one operation in the missioning one, then it will move, it will keep into the second mission. In the similar way, the automation culture we are going to, if you are going to implement in agriculture, like when you are going to crop cutting, okay, when you are going to cut the crop, what will happen? Cutting the crop, and nowadays I think maybe people have knows about a lot of missions are there. After cutting the crops, directly you will get the whatever the output, the seeds, you will get it directly. Okay, whatever the seeds, you will get it directly. What will happen? These machines will crush it and it will give the output immediately. And we can put one along with one truck, it can store into the truck directly. And also see, this type of automation will help to the several requirements in industry while helping the farmers to save the money and time also. They can save their money and they can save their time also at the same time. And what are the essential characteristics for robots when we are going to use in agriculture? What are the minimum essential characteristics is required? You can see here, when we are going to use the robots in the agriculture, okay, or in any industry, or if you are going to use any societal application, okay, in the place of human being, we are going to replace. Okay, that type of cases, what we need to do first, we need the sensing of the robot. Okay, how as a human being is sensing. Okay, in the similar way, robot should also sense something. Okay, how we have eyes, how we have nose, how we have ears. Okay, these like that robot should also sense it, like light sensor, touch sensor, hearing sensor, chemical sensor. Okay, suppose what type of chemical is smell is coming, that you need to identify. Okay, for sensing characteristic is required. Then movement. Okay, see actually what will happen when we are going to develop the robot. Okay, the robot is not in single place, it cannot stay in single place. Okay, like a mission, as a mission what it will do, it will place in one place only, it is a stationary position. But robot cannot place in at stationary position. If it put in stationary position, it is very difficult to do in automation, very difficult to do to lot of application. Okay, then robot can move from one place to another place. To move from one place to another place, I have shown you how it is doing surviving. Surviving means continuously it is moving in the field. Okay, you need to provide some wheels, you need to provide some wheels, or you need to provide some walking, like you how you may have legs, we need to provide, or you need to provide some snaking, you can use some skating. Different types of arrangements we need to provide to move the robots to around the farm or around the crop. And the third one is the energy. One of the most essential characteristics is required energy. See, as a human being, we need energy and we are taking daily food. Okay, morning breakfast, lunch, dinner. Otherwise, we cannot see. You just try it from morning to evening. We cannot take any breakfast or lunch, and our energy will last and we cannot perform, we cannot interest to do some work also. Like that, robots also need to already we need always we need to supply some power. Okay, how we are going to do? We need to supply the power in the place of like batteries, or it may be direct power, or it may be by using fuel generators. Okay, we need to supply the power. Okay, that is sufficient. And the fourth one is the intelligence. Okay, when we are going to intelligence, see, as a human being, we have our own intelligence. We know, suppose when we are going to walking, okay, suddenly there is some stair is coming. Okay, basically, as a childhood onwards, we have already trained. We have already trained. How we have trained as a mother or father or sister or brother, they have told us, okay, this is the stair. When it will come, you need to change your leg position like this. Okay, that means, and when you're going to touch something, it is hard. That means hard means then what will happen? We know this. If you touch this one, it will touch, it will be lot of heat will be generated, or it may be hot. Okay, that how we know our parents has they have already thought that intelligence we have. Robots don't have that type of intelligence. To become as a smart robot or smart agriculture robot, we need to do some intelligence. Then intelligence means we need to provide some programming knowledge, like neural network algorithm, how like deep neural network or machine learning algorithms, how we are going to provide. We need to provide some intelligence. Okay, we need to provide some intelligence. Based on the intelligence, the robot can take the decision and it can operate. It can take the decisions. Okay. Then see, coming to today's topic, what is Internet of Things? See here you can see Internet of Things. See, you can see in the agriculture how they are using. Okay, and this is called precision agriculture, and agriculture by using drone and smart greenhouse and stock monitoring. What it will happen in the Internet of Things here? It will take the data. Okay, it will take the data from the soil, or it will take the data from the livestock, and it will check the already cloud data. Okay, these all the data it will send to the cloud, and there will be processed, and it will give the decision. Okay, what type of crop is required, what type of pesticide we need to do it, what type of livestock, what is the height of the growth of the cattle. Okay, what is the type of health monitoring system, and what type of temperature is required in the smart greenhouse. Okay, how much light conditions is required. These all the things we need to control by Internet of Things. See, IoT is a system of interrelated computing devices. It is a system of interrelated computing. Interrelated computing device means we are using, there are number of electronics components like Zigbee, like sensor. We are going to use, there are number of electronic components we are going to use it. See, mechanical, see, it is a system of interrelated computing device, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers. Okay, see, when you're going to discuss, it is interrelated computing device, it is maybe mechanical and digital machines. It may be mechanical machine or a digital machine, objects or animals or people that are provided with unique identifiers. Unique means the same category, and the ability to transfer data over a network. Okay, see, whatever the data you are getting, like machines or objects or animals or people or cattle or whatever it may be, that unique identifier data we are going to provide, that will be transferred data to over a network without requiring human to human or human to computer interaction. Okay, without any interaction, without any human to human. Generally, olden days, what they will do, they will check by human being. Okay, each and everything they will count by human being, and they will enter the data into the computer. But here, no need to enter, no need to enter any data, no need to use any human being. Okay, here it can, by using these sensors, it can get the data, it can get the data from, it can get the data from the sensor, and it can send the data to the cloud. Okay, this is called Internet of Things. Then see, what is the opportunity? Why this IoT opportunity? See, world is digitally connected, and data from device can guide farmers' decisions. Okay, it can guide what type of decision they need to take, helping them farm smarter and safer and adapt more quickly to changing conditions. See, what it will happen? This based on the previous data, based on the data, it can give the suggestion to the farmer. Okay, it can give the suggestion to the farmer. Okay, how it will become a smart farming. Okay, how we can do a smart farm, and how we can do the safe farming, and what are the technological conditions will be there, what are the climate conditions are there. These are all the things it will be helpful. The ability to monitor farm conditions and infrastructure remotely can free up time, labor, and capital to invest, allowing farmer to focus other things. See, what will happen when we are going to provide the data? Okay, when we are going to controlling all these things. Okay, like cattle or like farm, the crop control, crop when it is coming, how many days it is going to grow, yielding. Okay, these are all the things when you are going to control by using Internet of Things. It will, the farmer, he can get free up time and labor and capital to invest. Okay, when you are going to invest the money and the labor or capital to invest, it can decrease, and allowing the farmers to focus on other things. Okay, when they will get the some free time, and they can try to focus to think other things, like how the secondary income they can generate it. See, the connecting physical resources in farms to in internet promote. See, the first one is the remote monitoring to farm conditions. Okay, by using the remote monitoring, the farm conditions and infrastructure, saving time and labor and routine farm checks. See what will happen when you're going to connect the remote monitoring. When you're going to connect the remote monitoring and the farm condition, how it is there. Okay, farm condition and the infrastructure, and also you can see the saving time. You can get the saving time and also labor and routine farm checks. See, if you are not checking by using this internet, if you are not using the internet of things, you need to put the labor. Okay, as a human being, you need to put one person to check all these condition. Okay, how the farm how the farm is there. Okay, and what is the infrastructure, you need to check it, and routine farm checks. Okay, you need to go every time the farm and you need to check what type of livestock are there, and what type of, if you go for agriculture, what type of size of the crop, what type of diseases are coming, we need to check by as a human being. When you are going to involve these internet of things, what will happen, you need to put the sensors and you need to take the camera, or you need to take the data from the sensors or camera, and you can gather the data, what is the size of the farm, these are what is the size of the farm, how many people, how many cattle are there, and what is the energy, what is the health monitoring system. Okay, these are all the things we can control by using remotely only. Improving producers decision making through data analytics, and see faster and quicker insights from real time data across the value chain, helping farmers respond to what the market wants. See, always what will happen, what markets wants exactly, what type, hello, what type of crop is required in the market, and what type of milk type, what type of milk is required. These are all the things we can check it by using in online only. Efficiency in how we produce the food to ensure less wastage, expediency to market, and enhance the traceability to demonstrate safe and sustainable food to our customers. See, when you're going to involve these internet of things, what will happen? See, efficiency, how we produce food. Okay, how we produce food to ensure less wastage. See what will happen. See, when you are going to use this technology, what will happen, we are trying to use the less wastage. When you are going to use the less wastage, what will happen, try to increase the cost, and also good quality of the products, we are going to increase the market and enhance traceability. Okay, and to demonstrate safe and sustainable food to customers, and building the capability to respond to new and emerging technologies. Okay, and we can, by using this IoT, by using this IoT, the person, those who are working this agriculture application, they can get emerging technologies. What are the emerging, and investing in research and development to contribute to ongoing innovation and improved productivity. And see what type of research is going on, research and development is going on, and to see to contribute ongoing innovation and improve productivity. See how we are going to innovate the new product in the agriculture, and also we are going to improve the productivity. Okay, what are the, we are going to do the cropping, and what we are going to the cattle farming, and all the things we can increase the productivity also. And coming to the advantage, when you're going to use this internet of things, what type of advantage that is? See, it can assist in the smarter control of homes and cities via mobile phones. I already discussed it. We can control these all the things. Okay, whatever the farm you are doing and whatever the things you are doing, you can control by using by smartphones. It enhances the security and offer personal protection. Okay, and no one will be store your data. They will not stolen by your data. By automating activities, it saves us a lot of time. You no need to go daily to your farm. Okay, you no need to go daily to your farm. You can see in the village daily what farmers they will do. They will go to morning to their farm. Okay, their field, they can go there and they can check it. Okay, and how water is there or not, what type of diseases are coming, these are all the things they can check it, what is the growth level of the crop. But no need to go always. Okay, it will save your time. You can sit and you can monitor everything through your mobile phone. Information easily accessible even if we are far away from our actual location, and it is updated frequently. How it will possible if you are not in your location also, you can through, see here we are going to use through your internet service. Okay, your Wi-Fi service, we can connect it, and it can possible to access it also. You can sit anywhere in India. Electric devices are directly connected to communicate with a controller computer, such as a cell phone, resulting in efficiency electricity use. As a result, there will be no unnecessary use of electricity equipment. See what will happen here. We are going to use the electric device are directly connected to the communicate with a controller computer such as a cell phone. Okay, directly what will happen? Whatever the data is there, the data we are going to connect with your cell phone. Okay, it will efficient electric. No need to use more electrical things. Okay, and finally you will get the no unnecessary use of electricity equipment. Personal assistance can be provided by IoT apps. Okay, we need to some personal to increase these apps which can alert you your regular plans. Okay, what will happen? How we are going to control all these things? We need to control by using your app only. That we need to check it updation. We need to check it always. It is useful for safety because it senses any potential danger and warns user. Okay, actually, it is when you're going to use this IoT, it is useful for safety purpose because it senses and any potential danger or warns users. Okay, anyone harmful to create also you can get it the data immediately, and it minimizes human effort because IoT device connect and communicate with one another and perform a variety of tasks without the need for human. See what will happen without any human interventions. You can do from starting to cropping and up to cutting the crop. Okay, when you're going to start and when you're going to cutting. Okay, all the how we are going to do all these things, whatever the things. Suppose initially we need to, okay, you need to plug your land. Okay, you need to plugging we need to do it in the land. Then we need to supply the water. Then we need to seeding, and there is a weed remover. We need to remove the weed, and after that what type of fertilizer is required, what is the soil moisture content, what type of nutritions are there. Okay, all the things we can do by one. Okay, step by step we can do it. You can sit in home and you can connect it and you can operate it also. Patient care can be performed more effectively in real time without the needs of doctor visit. Okay, it gives the ability to make choice as well as provide evidence based care. See here, you can see as a patient. Suppose if you go for in a patient in the hospital, see no need to go hospital. Doctor can sit in the home, and nowadays actually you can see the robot. Doctor can sit in the home. He can the online medical treatment. Okay, they are doing asset tracking and traffic and transportation tracking, inventory control. Okay, what type of asset is there, that will be we need to track it, and traffic and transportation tracking, inventory control, delivery, surveillance, individual order tracking, and customer management can all be made more cost effective with the right tracking system. You can see like Amazon or Flipkart. Okay, they're controlling. See, they are now they are involving these internet of things. When the person they have ordered the item, and when we are going to deliver, how many days it is taking to deliver the order, and while delivering what type of, okay, surveillance. Okay, how you are delivering, what type of delivery system we are using. These are all the things we need to check. Coming to the disadvantage, when you are going to use this internet of things, hackers may gain access to the system and steal personal information. Maybe whatever the data you have, your data is there, that data may be hackers, they may be hack your data. Since we add so many devices to the internet, why? Because we are going to connect some internet device. Okay, there is a risk that our information as can be misused. Maybe people they can use our data. Okay, they rely heavily on the internet. Why? Because here, see, why? Because you can sit in home also, you can control it. You can sit in anywhere in India, you can control your crop system, you can control your farming. Okay, you're controlling your livestock management system. How you are going to control it? You are always depending upon the internet. Without internet we cannot do it. Okay, how we are accessing from one place to another place with internet only. Okay, with the complexity of the system, there are many ways for them to fail. Okay, see, due to this the complexity, see, number of systems we are going to use it. Okay, number of connections we are going to. Okay, sometimes there are many ways to fail. Okay, we lost control of our lives. Our lives will be fully controlled and reliant on the technology. Okay, see, the completely we are our surrounding it move on the only in the technology, all internet, these all the things. Overuse of the internet and technology make people unintelligent because they rely on smart device instead of doing physical work, causing them to become lazy. See, if you're doing more thing in internet, if you're working in more thing in internet, what will happen? Suppose nowadays, actually, see, when people earlier they know about completely up to 20th table. Now what will happen when the calculator came into the picture? Suppose when the people, even in the engineering students also I observed, suppose if you will ask when you are going to teach in the class, okay, 16 into 16 9 just how much, then no one has giving the immediate response. Why? Because they are depending on the calculator. Okay, just what will happen, they are just typing, and otherwise they will open up their mobiles, or otherwise they will open their laptop, they will calculate and they can give the calculation. This type, if you are going to use more internet technology also, more internet, okay, if you are depending upon the more newly advanced technology also, it will create the lazy of the human being. It will create the lazy. See, and unskilled workers are at a high risk of losing their jobs. See, when you're going to use these all technologies, when you're going to use these technology, what will happen? Those who are in unskilled people, they may lose their jobs, and actually, what will happen? They need to survive their family because of one person will go there and do some work, but he don't have a job. Then the complete family will be lost the food. This is the problem, and they lost their jobs, which could lead to unemployment. Okay, this will be create the unemployment. Smart surveillance cameras, robots, smart ironing system, smart washing machines, and other facilities are replacing security guards, maids, iron man, and dry cleaning service. See, if you see in the future, next 15 to 20 years, or it may be 15 to 20 years, there are some of the things I have smart surveillance cameras. Already these things came in the market. Already people are using cameras, and robots also came. The smart ironing systems, smart washing machines already came, and you don't need to keep your clothes in the washing machine also. In future, what will happen? Robot will, if you purchase one robot, whatever the task you need to do from morning to evening, okay, whatever the class you are keeping there in that your machine, that it will take it and it keep it in the washing machine also. These all the things will be robot will do. Then finally what will happen? A human being become as a lazy. It is very difficult to plan, build, manage, and enable a broad technology to IoT framework. Okay, it is very difficult to plan what type of planning you are going to do, what type of idea you are going to build it, and how you are going to manage and enable, how you are going to start. Okay, this type of technology, as a unskilled person, it is very difficult. And these are the some of the advantages and disadvantages when you are going to use the IoT. And see, when we are coming to the agriculture, see what it will happen. See here, you can see I already shown the same photo in the first second slide also. When the robot is going to plug the this vegetable. See what will happen here. Earlier I have shown here there is a camera. Now there is a sensor in this, and it can easily identify this tomato is ready to pluck or not. Pluck or not. See, this agriculture to help increase the productivity while lowering overall costs. The agriculture industry has been actively working to adapt to different forms of robotic technology. Different, not only single, okay, not only for plucking purpose, they are going to use from starting to ending, okay, for starting the crop, okay, and for ending the crop. Okay, that means when we are going to cutting the crop, they are using all these fields in robots. Farmers have already been using tractors and harvesters that are self-guided by GPS. See, actually, maybe people they may know about. Maybe we already seen our villages in earlier what they are doing, what they how they are plugging and all the things by using bullock, by using animals. Okay, by using animals, they are doing all this farming. But recently, it came in tractors and harvesters. It came, but already came, it is going to come, some of the equipment already came, some of the equipment it is going to come. There is a driverless tractors, driverless tractor, driverless harvesters, driverless drones. Okay, these all the things are coming in the market. Recently there has been arise a and the experimental use autonomous systems that automate operation like pruning operation, like thinning, okay, moving, spraying, and weed removal. These all the things are doing in the autonomous. Okay, autonomously it is working. Pruning, when you are going to do your pruning, okay, thinning operation, moving, spraying, and weed removal in the your soil, okay, your farm, okay, it is doing autonomously. The sensor technology is also being utilized to manage pests and diseases that affect on the crops. See what how it will work from starting to ending. Okay, it will take the data. You are putting different types of sensors in different places, and also by using help by using monitoring system. It will take when the weed is coming immediately. You need to send the weed removal robot. Okay, when diseases are coming, you need to send the spraying robot like drone. And also always it will check it the weather monitoring. Okay, suppose if your crop is there and what type of weather conditions are there, it is always checking. And see what is the difference between automated and conventional technique. Okay, automated, what is the automated and what is the conventional? Okay, what is the indigenous technology they are using? The conventional techniques depends upon human power and old techniques. Okay, these conventional techniques always we need to depend on a human. Okay, you need to depend on the human being. Okay, and also it is a old technique. Robots can work non-stop. Humans need rest. See, already we have seen in the robots how the robots no need to work. No, sorry, robots no need to rest. Okay, we need to power only in the motors. Okay, you need to give some energy like battery operated, like direct power. But as a human being, as a human, we need rest. Human may not be able to work in hazardous environments, but robot can work in hazardous environment. Okay, large sized wheels required in muddy soils. Robot small sized wheels perform well. Okay, when you see, even though if you're going to use in the muddy soils, okay, you need to use the large sized wheels. Okay, otherwise it cannot come out. But robot can work with the small sized wheels also. Robots can detect presence of diseases. Okay, it can detect what type of and weeds. Okay, what type of weeds are there, and insect infestations and stress and other stress conditions. Other stress conditions. It can identify it. The light weight of the robot do not compact the soil as large machinery does. Okay, see, when you're going to see the light weight of the robots, okay, when you're going to use the light weight of the robot, do not compact the soil as a large machinery does. Okay, no need to compact. See, when you're going to use the robot should be lightweight and it will not compact the soil. Okay, if it is the machinery, when sometimes actually what will happen when you're going to use the machinery, that machinery, the conventional machinery, it should be larger weight. But if you go for this robot, it will be lightweight. And how IoT technology is benefits today's modern farming industry. You can see there are different types of application they are using. One is for water management system. Okay, when the soil is going to dry, you need to supply, and drones for field monitoring. Okay, field monitoring means here what will happen, and it can check it. Okay, what type of diseases are coming and what type of pesticides are there, what type of pesticides we need to spray. And also these drones will helpful to identify the cattle size. Okay, number of cattle size. Okay, what is the size of the cattle, what is the where it is there, number of cattle are there. And the missions for routine operations like plugging, pruning. Okay, and also like weed removal, like crop cutting, and soil monitoring sensor depends upon the soil monitoring sensor. It will generate the water, it will give the water. And see the structure of IoT in agriculture. Okay, you can see here IoT structure in agriculture. See, when you are going to use the IoT technology in agriculture, first what are the things we require? What are the things we require? Okay, we need to require sensors and device, and pH sensor, and we need gas sensor, we need ultraviolet sensor, we need motion detect sensor, we need PIR sensor, soil moisture sensor, temperature sensor, humidity sensor, barometric pressure sensor. See, these all the sensor we need. Okay, if without these all these sensor, we cannot involve this Internet of Things in agriculture. Why? Because these, see, we need to measure what type of weather conditions, what type of, okay, climate changes, when it is changes climate, what is the soil type. Okay, what type of soil is there. Okay, we need to identify what are the inserts are coming in the motion detector, we can use it. And okay, these are what is the temperature is there. All these type of sensors we need to use in agriculture. Okay, then only it is a IoT, it is the Internet of Things. Otherwise it is not smart agriculture, then only it is a smart agriculture. Otherwise it is not smart agriculture. But how it will be applications, how it will be depends upon this these all the data. Okay, it is getting, there are a lot of data, different sensor we are getting. Okay, how these data will use in different applications. Okay, see, when you're going to discuss about the applications point of view, see, one is the livestock management, and second one is the precision farming, third one is the greenhouse monitoring. One is the livestock management, second one is the precision farming. Third one is the greenhouse monitoring. And we are going to discuss about the livestock management. Livestock management, see here, one is the livestock management, animal health monitoring. Okay, here in the livestock management, what we here you can see the animal health monitoring and heat stress level. When you see what type of temperature is there and what is the stress of the animal, and physical gesture recognition and where it is moving exactly. The livestock means the animals. See, we can identify the health monitoring system. We can identify the stress, how the animal is behaving, any stress is there, and physical gesture recognition, where it is moving, and rumination. Rumination means what is the digestion system of the animal. Okay, you need to identify the digestion system of the animal. Okay, heart rate and GPS based monitoring. GPS based monitoring, where different types of animals, where it is there in the field. Okay, these all the things we can identify. Coming to the precision farming, you can see climate condition monitoring. Okay, how the climate is there. Okay, what type of climate is there, and soil patterns and different what type of soil is there. Okay, what type of things required, what type of nutrition, what type of fertilizers we need to add. Okay, in the soil, whether it is there, what are the things are there, the sulfite is there or nitrogen is there or it may be zinc is required. Okay, it can identify. Okay, it can identify. Pest and crop disease monitoring, pest and crop diseases monitoring. Then you can see irrigation monitoring system. Okay, the water, when we want to supply the water. Okay, the irrigation monitoring system determine the optimal time to plant harvest. Okay, see how the actual, when we are going to the harvesting time, if you are doing any farming like paddy or corn or any, okay, like any vegetables, how we need to the crop harvesting in optimize it. And the tracking and tracing where it is there, your product, your crop, and when you're going to send somewhere, okay, to market, you can track it also. And farm management system, okay, how we are going to do all these things from starting to ending. Okay, when you're going to seeding, then to when you're going to send your crop to market. Okay, these all the things are farm management system. How these all the things will be step by step process. Then coming to greenhouse monitoring. See, some people they are using based on they are developing some shades on the on the bottom of the shades. They are doing farming. Okay, that is called greenhouse monitoring. That is called greenhouse monitoring. Here they can see how the water management and plant monitoring system, how the plants are the growth level. Okay, what type of diseases are there, and what is the weather monitoring system in the inside the sheds. And agriculture drones, see here the agriculture drones always they can use for to monitoring, or otherwise they can use for to spray something. Okay, to spray spread any pesticides, or you need to provide anything, or it may be go on monitoring the complete the system. Okay, see these are the different types of applications they are using in agriculture. But these are the applications can possible when we are going to use all these type of sensors, then only it can be possible, otherwise it cannot be possible. And see, coming to different applications, see the robots you can see in this picture, it is used for nursery planting. See what will happen in the nursery plants, initially they will put some bowls, or it may be some maybe polythenes, they will put some soil and they will put some seeds. Okay, but after making, there is a very big nursery plant. If you want to move, depends upon the temperature conditions. I want to move my plants from this place to morning. I want to keep for sunlight purpose. In evening, I want to move from here to here. Okay, for that purpose, you want to move your plants from one place to another place. If you use as a human being, if you use any labor, the cost will be increased. To move from one place to another place, you can use the robots. See, you can see in the picture, the robots can carry the plants, or it may be any customer is ordered. Suppose I want to need rose plant. Okay, I want to need some jasmine. I want to need apple. Okay, the robot will go there exactly where the all roses are there, white roses are there, red roses are there. Okay, where the jasmine is there, where the apple plants are there, robot will go there. It is a very big farm, maybe 5 acres, 6 acres, or maybe 100 acres, like nursery plant. There it will go there, and robot can pick your, okay, robot can pick your what type of plant you require. Robot can pick and it can give the customer. This is the one of the application they are using. See, nurseries where seeds are grown into the young plant, which are later planted outside. Okay, which are later. Nursery plants are often sold direct to consumers and landscape gardeners, but they are also start the food journey for some crops. See, when you are going to sell it, all these things. Companies like Hito Agrotechnics and Harvest Automation provide automation solutions for seeding, potting, and warehousing. Okay, warehousing living plants in greenhouses. Okay, here what will happen? These robots, it can go there. It can how to do seeding operation, how to do move from one warehousing operation, warehouse to move. Okay, from one place to another place where it is there, the exact plants are there. Then crop seeding. See, when we are going to see the crop, see now the soil is ready to, okay, it's ready to put the seeds. Okay, how to do the seeding? Okay, see there are different types of seed management system. You can send the seeds by using your drones also. Okay, or you can send by using your land. Okay, land robot. Okay, this robot can move in the land. Okay, you can do soiling by using what this app, what this robot here they are using. Okay, earlier they are using these all by using manually, and after that manually they have done, and after that by using some tractors or some, okay, some mechanical element they are doing this seed cropping, crop seeding. See, many food plants begin life as a seeds in the field. Okay, whatever the food we are getting, it will start from the seed. Okay, it will start from the seed. The traditional method for sieving seeds is a scatter them using a broadcast spreader attached to a tractor. Okay, what will happen when you are going to sieving the seeds in a scatter? What will happen? It is a broadcast spreader attached to a tractor. This throws many seeds around the field while the tractor drives a steady, okay, a steady pace. It is not very efficient method. What will happen when when we are going to do this operation by using this tractor and any mechanism? Sometimes maybe number of seeds will maybe fall down. Sometimes may not be fall down. Okay, due to sometimes it may be fall down. What will happen? It may wastage. Okay, sometimes only soil is there, but there is no plants. Okay, why? Because there is no seeds. Maybe fall down there. Okay, to avoid this type of things, they are going to use the autonomous robot seeds. Okay, see, autonomous precision seeding combines robotics with geomapping. A map is generated which shows the soil properties, quality, density at every point in the field. Okay, then you can understood now what is the moisture content exactly, where I need to put the seed, and also it can the where it is already each and every place. Okay, each and every place, and there is no wastage. There is no wastage. The tractor with robotic seed attachment then places the seeds at precise locations and depths so that each has best chance of growing. See, eh, when you are going to use the tractor, if you can use the robotic seeding attachment, okay, directly when you're going to use the mechanical missions, you can use it robotic the seeding attachment. Then what will happen? It can go to each and every point, but how much depth you need to put your seed, how much depth is required, how much depth is required, exactly in that depth, how much depth is required, exactly that depth level this robot can feed the seeds inside the soil. And the crop monitoring and analysis. See, these are the different types of applications I'm going to discuss. One is the nursery, second one is the crop seeding, and crop monitoring analysis. Now you can see here, after seeding, okay, the plant slowly the plants came. Okay, now you need to check every week or every day. Okay, what type of crop type is there and what type of diseases are coming, and whether the water is required, whether the temperature is more or okay, what are the climate conditions. These are all the things we need to check it. See, for that purpose, what will happen? I already told you earlier. Earlier, the people they are using indigenous technology. Okay, now you can use this advanced technology. Okay, the robotic technology. See, monitoring huge fields of crop is a big job. Suppose some farmers there may be doing cropping in 1 acre, 2 acres, they can go there and they can check it. But if you are going to crop, like if you go for advanced countries like foreign countries, US, Australia, China, the people they are farming. I think India will also come the same situation maybe after next 20 to 30 years. Who they will not farming the big companies. Okay, there is a big industries they are farming. The farmers they are not farming. Only the companies they are farming. It is also like okay one job type. Okay, what they will do, they will do farming like 1,000 acres. Okay, 2,000, 10,000 acres. But it is very difficult to go as a person for each and every plant and each and every place. Okay, what they will do, and they will monitor by using these drones. Okay, they will monitor. Okay, one person will sit and he can operate the drones. Okay, and he can sit in the room. Okay, and he can get the data. He can get the data from the this drone. See, new sensor and geo mapping technologies are allowing farmers to get much higher level of data about their crops than they have the past. Okay, whatever the past they have data, compared to the past data, they will get the higher level data. They will get the whatever the lot of data, you will get higher level data about their crops. Ground robots and drones provide a way to collect this data autonomously. See, instead of going, maybe drones may fly away from the ground. It may be air, it may be flight. When you go, when you are going to use ground robot, maybe that means that robots, it may move on the ground. It will go and collect the data autonomously. Okay, the ground robots, it may collect from the data through ground, and drones maybe fly and can collect the data with autonomously, no need any human intervention. Drone companies like Precision Hawk, okay, one of the company, the drone company, the Precision Hawk, offer farmers combined package which include robotic hardware and analysis software. Okay, what will happen, they are offering, they are developing some robots, that robots, it will do hardware and software. Okay, and the farmer can then move the drone in the field, initiate the software via tablet or smartphone, and view collected crop data in real time. Okay, what will happen, you just leave the drone in the farm, and you can operate by the drone by using your smartphone, and you can collect the data in real time. Okay, then ground based robots like Boni robot, this is the one of the company, Boni robot provides even more detailed monitoring as they are able to get closer to the crops. See, in the drones, actually, it is not very close to the crop, but it is little bit away from the crop. But it can move in the throughout the cropping, throughout the your farm. But these ground robots, what will happen? It will go very nearer to the crop, each and every plant, and it can give the data. Okay, even more detailed monitoring as they're able to get closer to the crops. Some can also be used for other tasks like weeding and fertilizing. Okay, maybe some of the robots, this Boni robots, you can use for maybe weeding, okay, to remove the weeds, and you can do for fertilizing operation also. And then fertilizing and irrigation. See, some of the robots we can use for irrigation and fertilizing crops. Suppose, hello, yeah. See, what will happen in the irrigating means what will happen, sometimes there is no water scarcity is there and there is no rains. But you need to provide the water for each and every plant. How we are going to provide? What type of technology we are going to use? Okay, there is a water scarcity in that area. We have to provide the sufficient water, how much water is required. Okay, actually people are using some indigenous technologies like maybe they will use drop by drop by using some pipes. Okay, drop by sprinklers they are using. In the similar way, here also robot can go to each and every point, each and every plant, and it can drop how much water is required for that plant exactly. Okay, it can drop it. Irrigating and fertilizing crops as traditionally used, a lot of water is quite inefficient. Okay, this fertilizer also at the same time when you're going to supply the fertilizer, it will go and it will drop exactly where it is required exactly. Robot assisted precision irrigation can reduce wasted water by targeting specific plants. Okay, what will happen when you're going to use these robot assisted? Okay, assisted by using robot technology, we are going to provide the water. It will try to reduce the water wastage. Okay, it will try to reduce the water wastage. Robots autonomously navigate between rows of crop and pour water directly at the base of each plant. See, there are two types. If you can use the drones to supply the water, it can spray it. And if you use for ground robots, it will go to exactly the place and it can supply the water for each and every plant. Robot also have advantage as they to access area other missions cannot. Okay, see the missions, when you go for discuss about the missions, it may be there is a huge space is required, and sometimes it may your crop may spoil also. But robot, it can, you can get the robots for small size to big size. Okay, depends upon your what type of crop you require, what type of robot you it is going to enter into your crop. Okay, depends upon your purpose. You can choose that robot also. And see the corn growers. Corn growers face a problem that the plants grow too quickly to reliable fertilize them. See, corn growers may see here what will happen if you go for any corn cropping. What will happen? It is very fast growing. The corn plants are growing very fast, but it is very difficult to go inside and provide the fertilizer for each and every plant. You can see in villages the corn how it is going plant. In 1 month it is growing too much. It is going around 5 feet, 4 feet like that in 1 month only. Two, after rising the 4 feet level, it is very difficult to enter as a human being inside, and it's very difficult to enter the any mission. What would will happen? There is a some small robots, the corn growers robot. It will go inside and it will supply the fertilizer for each and every plant very fastly. That is called that robot is called robot. Okay, what type of robot they are developed? That is name is called robot. Okay, the aim is to solve this problem. Is that easily drives between the rows? Okay, why? Because for one row to another row there is a some gap. It will easy to move in that rows of corn and targets nitrogen fertilizer directly at the base of each plant. Okay, this robot means this is the one of the name of the robot. It will go each and every plant. It will try to supply the whatever the nitrogen fertilizer required. Okay, it will directly supply that plant. You can see there are different types of agriculture robots and crop weeding and spraying. See what will happen. Spraying pesticides and weeds killer onto fields is not only wasteful. Okay, see the spraying pesticides and weed killer. Okay, weed killers onto fields is not only wasteful. It can several harm them environment also. Okay, it can several harm. See whatever the pesticides you are going to spraying. Okay, and that's by using spraying and what will happen? Whatever the insects it will die. But it is not wasteful only and it can sever harmful to the environment. Okay, robots provide a much more efficient method. Okay, it will not going to more spreading in the environment. It can be supplied directly on the plant only. The concept of micro spraying could significantly reduce the amount of herbicide used in crop growing. Okay, what will happen by using this micro spraying? It can supply, okay, significantly reduce the amount of herbicide. This is the one of the chemical when you're going to use the this pesticides. And micro spraying robots use computer vision technology to detect weeds. Okay, where the weeds are there and spraying targeted drop. Okay, where weeds are there and there you can directly spray it. Then your weeds will be died. It will be killed. Target drop herbicide onto them. AG Board 2 is a solar powered robot which uses this technique. This is the one of the robot. The name is called AG Board 2. Some weeding robots don't even need to use of chemicals. Some of the weeding robots no need to use any chemicals to kill the weed. Okay, RoboCrop, for example, uses computer vision to detect the plants as it is pushed by a tractor. It then automatically hosts the spaces between the plants to uproot the weeds. Other weeding robots use lasers to kill the weeds. See what will happen here. Some of the weeding robots like RoboCrop, by using this computer vision, how you need to plug it. Okay, you need to this tractor. How we are going to do the plugging operation? It can do it and it can remove it also, and also it uses some host the spaces. Okay, automatically host the spaces between the plants to uproot the weeds. Okay, and also they can use some weeding robots use some lasers to kill the weeds. We are going to use some laser technology also for killing the weeds. And thinning and pruning. See, coming to thinning, see what will happen. Thinning means see involves reducing the density of plant so that each has better chance to grow. That means what will happen sometimes when you're going to seeding. Okay, I told you by using when you're going to use normal indigenous technology, number of seeds will be fall down in the same place and number of plants will be come in the same place only. But due to the number of plants will come in same place, what will happen? Whatever the nutrition is required, no one plant can take the sufficient nutrition. Then it cannot give your satisfactory crop. Okay. To avoid that one, to avoid that density, we need to remove some of the plants and we need to give the chance to growing whatever the good plant is there, whatever healthy plant, we need to give the chance to growing and it will provide the more crop. Okay, that is called thinning. Okay, by using we will remove that what are the not healthy Okay, only healthy plants can grow it. Unhealthy plants can remove it. Pruning involves cutting back back parts of plants to improve their growth. See, some of the plants we need to cut their stems. We need to cut their stems. For cutting their stems, when you're going to cut the stems, okay, what will happen? The plant's growth will be increased. Okay, that is called pruning. We need to cut. See here, we are going to use. There are two different types of robots. One is Litas bot, is a thinning robot, and this is the Wall E. This is the pruning robot. The thinning robot, Litas bot, is the thinning robot received a and what this is. See what will happen. This robot can use by using the computer vision. Okay, it can detect it. Okay, what type of plants are there? How many plants are there? How many plants are there? And how many plants are healthy? How many plants are not healthy? If they are not healthy, it can remove it. Unhealthy plants, you can remove it, and it can then only whatever the healthy plants are there, it can take the more nutrition from the soil. It can grow it. Similarly, the pruning robot. This is the one of the robot. Here, what will happen? This pruning robot is also do the same task. Whatever the unnecessary stems are there, it can try to remove from the. It can try to remove from the your plant. It can remove your maybe it can remove your plant. Using tractors. I think all people know about tractors, but it is a driver. Okay, by using driver, it is driving the tractor. But here, the people they are going to we are going to use the autonomous tractor. Why? Because all what are the things I'm going to discuss. I have discussed in the today's session. Different types of robots from starting to nursery to crop seeding and crop monitoring, fertilizing, crop weeding, and thinning, pruning, autonomous tractors. These all the things are connected to your internet, the cloud computing, and from starting to ending, no need to go your farm, no need to do anything. Okay, no need to do anything to as a human being. You need to operate by one. First, what you are want to do seeding operation. One robot will go and need to do, but you need to provide all this type of technology, all these type of robots. You need to provide the technology nearby your farming. Several of the robots have mentioned are attachment to a tractor. As the humans usually drive the tractor, the robots are designed to adapt to speed that humans is driving. However, fully autonomous tractor also becoming popular. See, earlier, what on as a human being as a driving the tractor, and also the speed and all the things we can control as a human being. But these driverless tractors no need to use any human being, and the speed of the tractor also it can control autonomously. It depends upon the way it is working. This is the one of the robot. It is IDTech X agriculture robot. See, report found they more than 300,000 tractors with autonomous functionality were sold in 2016. See, already these all type of tractors came in the advanced countries like US and Australia. They are using this technology. They are using. There is also rising trend for follow the leader autonomy, where tractors autonomously follow human-driven combine harvesters to collect the grain. See what will happen when you're going to cut the crop. Also, it will go follow along with the crop cutting machine, and it can cut it also. It can cut it, and it can follow exactly and collect the whatever the crop is there. It will collect it also. Then picking and harvesting. Okay, the final. See now what will happen here? The cropping, the autonomous tractors, and we are going to do picking. See, I already discussed from starting onwards how the robots were going to crop cutting. Okay, like any paddy or it may be corn or it may be any apples. Okay, but when you're going to use the soft fruits, like any soft fruit like oranges or any soft fruits, we need to use their gripper. Okay, that pneumatic gripper we can use it. How much pressure you need to apply for gripping? Like grapes, suppose if you want to picking the grape, okay, if you use mechanical gripper, what will happen? It may press it and it may spoil. The grapes will be spoiled. We use the soft gripper. I have shown in the first load how the smart gripper is there. Okay, by using pneumatic system, we can control. And the other is sheep herding and herding. Okay, what it will happen here? By using this internet of things, we can control. Okay, what is the cattle growth is there? What is the health condition? What is the how many cattle are there? We can see. Although most agriculture robots are currently applied in crop growing, there have been few emerging applications with sheep and cattle farming. Okay, see most of the agriculture robots for crop, and but some of the few applications that developed, that is for sheep and cattle farming. Okay, here what will happen? Suppose we are going to farming the thousands of cattle. Okay, thousands of cows, thousands of sheep is there. It is very difficult to monitor each and every cattle, each and every sheep. It is very difficult. Okay, when you're going to monitoring each and every cow or each and every buffalo or each and every sheep or each and every hen, there is a lot of human power is required. Okay, here what will happen? Suppose if you want to go for do the some milking, okay, to do milk, okay, the cow will go there. You can see internet. There is a lot of video are available. The cows will go there and it will stand one mission, and there is a automatic music system will come. It will go to near the ears, and automatically the milk spreader, it will go to near the place and it will try to take the milk. Okay, this is the technology they are using when they are going to farming the 1,000 or 10,000 like cattle they are farming. Okay, and this is the milking operation. I already told how the cow will come into stand here, and they will use some music system, and there is a robotic machinery. It will go to the nearby the cattle, and it will try to feed the cow. It will try to feed the milk. See, the great deployment use collaborative robots to help in the milking process on dairy farm. Okay, collaborative robots means it can controlled by as a human as a collaborative. See, these collaborative robots, what will happen when you are going to it will be operate in the place of human being also, but it will not damage. It will not create any damage to human being. Okay, the robots can be used to spray disinfect on the cow's udders in preparation for milking. Okay, before going to take the milk, what will happen? First, initially, they will try to apply some disinfects in this place udders, and what will happen? What are the germs will be there? It will die. Then you need to take the milk. Okay, this is the one of the technology. It seems certain that robotics will continue revolutionize agriculture and change the way that we think about producing food. See, these robots nowadays actually when these all the robots are coming into the market, and you will try to changing the revolution. And see, IoT in agriculture challenges. There are some challenges. One is the hardware challenges and network challenges, and you can see IoT agriculture platforms and other technical issues also. And see, when you are going to discuss about the hardware challenges, see, all the equipments which exist at the perception layer are directly exposed to harsh the environmental experience such as rain, high level temperature, extreme humidity, hard winds, and many other possible dangers for destroy the element. What will happen? You are going to keep your sensors and all the things in different places in the crop. It may be suddenly heavy rain will come, suddenly the temperature may increase, suddenly the wind will be more increased, and these all the things will be what will happen. Whatever your electronic circuits are there, it may try to damage. Okay, that this is the hardware challenges. The people they are working, how it will be smart, how it will be possible to overcome these type of problems also. Okay, then coming to the network challenges. Network challenges means here what will happen when we are going to implement the hardware. Okay, then you want to transfer your data from one place to another place. How we are going to transfer your data from one place to another place? You need to transfer by using wireless communication. Okay, see, due to the high cost of wiring, wireless communication is the most important for the deployment of IoT based agriculture. See, this sometimes see physical deployment shows the accepted transceivers performance exaggerated by human presence, temperature, humidity, and many other barriers inside the space. See what will happen when we are going to sending the data from your farm to in your home. Okay, you are there in the home and your farm is there. It is maybe 500 or 100 kilometers or 10 kilometer distance. Due to these all temperature, humidity, okay, and all these all the things also, maybe in winter there is a too much cold. This may be problem will also to get the data from to wireless. If it is a wire, no problem, but the cost will be increased. Then coming to agriculture platforms, IoT agriculture platforms. See, IoT agriculture architecture is more complicated to compare to other IoT end device and require real-time monitoring system with additional stringent requirements. See, when you're going to discuss with agriculture, when the IoT you are going to involve in agriculture, when compared to other applications, it is little bit complicated. Little bit. Why? Because you need always real-time monitoring system. We need always real-time monitoring system. And what will happen here? We are going to use, there are number of libraries, okay, and number of library and different APIs. We need to use the programming and all the things. Okay, this is the one of the challenge in IoT agriculture problem. And there are some technical issues: the interference problem, reliability problem, scalability problem, resource optimization, cost analysis, and lack of knowledge of technology, mobility problem. These are the different technical issues. These are the challenges people are working: hardware challenges, network challenges, and different development of agriculture platforms like apps, agriculture apps, and the interference problem, reliability problem, scalability, resource optimization, and mobility, cost analysis. These are the applications people are working. As I said from the starting, at present we are working on project in agriculture application. That is the coconut coconut harvesting mechanism. This is completely. We have this is the CAD model. This is our idea. We have developed. This is the mechanism, and we are going to make it on the top. We are going to make it a one manipulator. It is a 2 degrees of freedom manipulator. We are planning to make it, and this is the upper layer. Our aim is to move this manipulator the circumference of the around the circumference of the tree, the coconut tree, and also we are trying to use these wheels, mechanized wheels. Okay, completely mechanized wheels, and also we are trying to operate this mechanism also around the tree, and this is the work we have already tested. When I was in Vigyan University, already we have tested. Initially, we have done. This is the prototype model, and you can see also we have supplying the whatever the electrical power we are supplying through wire. That's why this is the why we are supplying the electrical power, and the remaining things we are controlled by using mobile app only. This is the one work, and thank you. If you have any doubt, I'm stopping up to here. If you have any doubt, you can ask now.
Sir, I have one question.
Please, please.
Sir, if I install a camera near a crop, and at the same place I have installed some soil properties, humidity sensor and another sensor. So is it possible to capture both that through camera some disease on plant and some soil parameter to take this simultaneously, and to collaborate this to detect if there is any disease present in crop or not?
You are asking about you are going to keep one camera nearby the crop, okay?
Yes,
And
to detect this
also you are going
if there
to,
is disease.
yeah. What will happen? What will happen? Through camera, we are not immediately, we cannot give the solution. Okay, what type of diseases is came? The camera,
Okay.
it will take the whatever the plant's picture is there, it will take it, and it will send
Okay.
this data to the server.
Okay.
There, what will happen in the server? What will happen? By programming that, I already did the challenge IoT agriculture platform. Here, what will happen? What are the diseases are there up to now? Okay, we are going to keep the data. We are going to feed by using some machine learning algorithm. Okay,
Okay.
what will happen? By taking your picture, then it will go to your processor server. Okay, and there it will check if this map, whatever the picture is there, this picture is exactly coincide with which type of disease. Okay, then only it can
Yes.
identify this is the type of disease. Okay, otherwise it cannot identify. Okay, without
Okay.
any this machine learning, it cannot, without any programming, it cannot, the camera, it cannot give the data directly. It can take the picture and
Oh,
it will
yeah.
send the processor, and it can identify the your what type of disease is there.
Okay.
That
And
is only it is.
if this is possible,
Please.
so then which board will be suitable for doing both of this? Means calculating soil parameters and as well as taking photographs of the crop. Means
You are asking about one
Arduino
more
Uno good.
no, 1 minute. You are asking about one more firing also.
Uh, sorry.
I'm not getting. You are asking firing also at the same time.
No, no, not taking pictures
Please.
of crop and
Uh,
also taking soil parameters from the soil. So for
Yes,
this
yes.
purpose, which board will be suitable? Arduino Uno is alone enough, or we need to interface Raspberry
No,
Pi board also with
actually,
Arduino?
these Arduino actually it can support up to some level only. Better when you want to run these machine learning algorithms, you can go for Raspberry only.
Raspberry only alone Raspberry Pi can do this thing.
Can do it can do. Why? Because it can capable to do. There is a lot of these machine learning algorithms. It can go there. It can Arduino. It can go up to some level only.
Okay, okay, okay. Thank you, sir.
Thank you. Thank you. Yeah, thank you. If actually I am working on robotics. Just we have started from the last 1 year onwards. This Internet of Things. One scholar is working under me. If anyone want to interest to work, actually we have started recently only how this IoT related to agriculture robotic applications. But if anyone, if you have any doubt in future, you can contact me. It is there in my all email ID, my WhatsApp number. It is there in my website. Thank you. Uh,
Thank you, sir. Uh,
Dr. Viswanath. Thank you, Dr. Viswanath ji, for
Thank
giving
you,
this
sir.
opportunity.
In a very short period of time, uh, you are available with us, without intimating
हाँ,
too much time before. So, sir, we sincerely
okay, okay.
appreciate you for taking out time from your busy schedule to provide us with such valuable information. And I wish you a great luck for all your future projects. And hope so, sir, ki we will meet you soon. So, thank you,
Thank you,
sir.
thank
Thank
you,
you.
thank you.
Thank you, sir.
Thank
Thank
you.
you so
Bye.
much. So, participants, our next session will be started on 11:30, and at 3 p.m. there is a validity function. So it will goes to from 3 to 3:20 p.m. At 3:30 we will start the test. So test will consist of 50 MCQ questions, and test will started from 3:30 to 5:30. So you have 2 hours for the solving the test, and minimum 60% is mandatory for passing the test. So thank you so much.